So let's start with the most foundational question. What is system design? So system design in general is we have a set of requirements and we want to build a product out of it. That's what system design is all about. So when someone says, hey, let's design a system. Now, it's a very generic term, design a system. What it typically means is we need to decide the architecture of it. That hey, if let's say I want to build the next Facebook, what all things would I require? I'd require a database to store it. I'd require database to store the data. I'll require API servers to serve the request, right? I need CDNs to serve images and whatnot, right? All of these things, it's about how your high level architecture would look like. What all components would you need to power this entire system? Second is you need to decide the components. Now these components is, hey, if I talk about Facebook, I want to design entire Facebook. That is my entire system. But in Facebook, there would be one module that is taking care of authentication authorization, right? But within that authentication authorization, I have one web server, I have one database, I have one cache. Those are components within it. So deciding the architecture, deciding the components, right? And then we need to decide modules within that. That hey, while I'm implementing this authentication, what all modules do I require? So system design typically comes in these three very strong flavors: your design architecture, your design components, and your design modules. So, and more importantly, when you design all these three, how different parts of the system that you design, they come together, how they would interact with each other to solve the bigger problem. The solving bigger problem is to build Facebook, right? And you solve individual problems and you define how they would interact with each other. And when you do that, that makes your system almost complete, right? So this is typically how product development happens in an organization. You join any company, this is what your product development life cycle actually looks like. You decide on architecture, you decide on components, you decide on modules, right? So which is why system design is so popular today, because every single tech product is a system that has been designed. Companies are building product and need all of you to design it, right? So which is why, because it's so closely related to how companies typically do quote unquote product development, that's why everyone is focusing on system design, because this is what is closest when it comes to what you do at work. And which is why it is really important to understand system design. First point, because this is what people do at work. Engineers, product managers, this is what we are supposed to do when we join a particular organization. We are there to build products. We are there to solve problems. Solve problems using real world things like databases, caches, CDNs, servers, compute, encryption, decryption, whatnot. And which is why this is the closest that we get to what is practically being done in an organization, right? Okay, when you join an organization, this is what you would see right from day one. Once your onboarding is done, once you give your photo proofs and identity proofs and whatnot, once you join the team, you become part of the team. The first thing that is handed out, hey, this is basically this is the product that we build. This is the things that we drive. This is the architecture of it, or basically these are the design documents of it. Go through it. This is what system design is all about. So this system design is something that is really very close to what we do in our day-to-day world. That's why it's so popular, and everyone can relate to it. That's why it is gaining so much popularity, because people are not just solving something made up, but something that is actually being done on a day-to-day basis. Right? And final thing, why understanding system design is important is because once you grow in your career from an entry-level engineer to senior engineer to tech lead, as you grow in your career, you will spend 80% of your time designing systems. Implementation, you will still do, but when you grow in your career, it's all about system design. It's all about how you are designing the best architecture possible that would help companies build the best solution out there with minimal cost. And which is why it is literally relevant for everyone out there, everyone, because this is what we do when we join a company, right? But there are some side effects of doing system design. First, it will make everything else seem uninteresting, right? Because this is what we do. This is what, because you would be engrossed in this problem so much that you will find, oh, that other thing is okay, but let me see how I can solve authentication problem. How can I, like, my response time is little high, how do I solve it? And that is so interesting, because you will get, when you make that optimization, when you build that system, and when you see users using it, that's the best feeling out there, right? And you solve real problems. Like, you solve real problems, not something made up. Typically with data structures, algorithms, you typically find some made up situations, although they are still used. I'm not saying that, hey, data structure algorithms are not important. They're still in use. But with system design, you are actually using that product. So it's much more relatable, right? When you think about relatability, system design is much more relatable than that, right? And the best part is, when you design the system, you learn how to break down a big problem statement into smaller solvable problem statements, and you solve individually efficiently, and then you combine all of them to solve that big problem. So it will rewire your brain into thinking in a very structured way. When you think in a structured way, what happens is, it would help you not only into designing good systems, it would help you in a lot of other aspects of your life as well. So it actually does that, when it just makes you a better thinker in general, right? And best part, you would consider all cases, fault tolerance, availability, and you can literally find correlation to how we live, right? Okay, so what will we do? What will we do when we design system? So we would break down the problem statement into solvable subproblems. Then we decide on each component that we have, that, hey, these are the key components that I have. These would be the key responsibilities of each of the component. We decide boundaries on it, because we don't want to have two components doing something very similar. Like, if one component is taking care of authentication, why should other component take care of authentication, right? Something what we do with our normal code as well. If one function is doing it, let's just reuse that rather than reinventing things from scratch, right? So we decide on boundaries of each component, and for every single component that we have, we would talk about the key challenges that comes in scaling it. When we talk about the key challenges when it comes to scaling it, that's where you see the magic of how things are scaled, how to think in an intuitive way to build scalable systems, right? And while we do that, it's not just about scale, but also about fault tolerance and availability. That, hey, what happens when a small component that you didn't know even existed, if it goes down, how will you make your system, how will your system recover from that? These are important things, important important major details that a lot of people skip. A lot of people skim through it. Okay, I'll take care of fault result. But these are really important when you design real systems, which is what I would try to inculcate through this course, right? So these are things that we would do for every single system we cover. The flow of it would be, we would first cover a lot of theoretical part in a practical way, building that strong foundation, and then we cover a set of very interesting systems, each varying very differently from other, and helping us become better engineers in this, right? So this is what is a basic introduction of what is system design. And in the coming videos, we'll take practical examples to understand how they are built, how to approach applying first principles to, and build an intuition around solving such problems, right? So I hope you found it interesting. I hope you found it amusing. That's all what I wanted to cover in this one. I'll see you in the next one. Thanks, Atal.